Hello YouTube! Welcome to the fourth video in this React testing series. During this video, I'm going to show you how you can test asynchronous code. Usually, asynchronous code is where I see people struggling the most in their React testing journey. And I will show you some examples at the end of the video where people struggle quite a lot. Now, for the ones of you that are probably asking, what is even asynchronous code? Let me show you once again our counter component. And at the moment, this counter is completely synchronous. So I click in the button and immediately the state will update to have the number 1 over there. I click again and immediately I will have the number 2. Now let's say that instead of having this state on the front end altogether and being synchronous, let's say that I click on the plus and I will have to do an HTTP call to my server, and my server will tell me that the next number is, for example, 10. Only when I have that number, I will update my counter. That way, I added some delay into my application. This is no longer synchronous code, is what we call asynchronous code. My example was an HTTP call, but we can achieve the exact same thing with a set interval or a set timeout, or if you are doing a debounce when you are typing in a text field. Those are all cases of asynchronous code, that you need to wait a specific amount of time or you need to wait for an action to happen in order to then test your code. And usually if you ever use tools like Selenium or stuff like that, you probably saw a lot of times that people were doing sleeps in the code. Luckily, in React Testing Library, we don't need to do any of those because React Testing Library provides us with a lot of those findBy methods. In the last video, if you remember, I showed you a few of the getBy. I showed you the getBy text, the getBy role, the getBy label text, and I even talked about the getBy test ID, even though I told you to not use that one. But we talk about those. The findBy methods, instead of going synchronously like the getBy, they will go asynchronously. So as you can see over here in this example, we will use the await keyword in order to wait for something, and then this will return a promise. And we will use, for example, the findBy text. And the way this works is that the findBy text will go after 50 milliseconds and see if the clicked once text is already on the DOM or not. If it's not, it will wait another 50 milliseconds, for example, and you can define these values by yourself. By default, they are 50 milliseconds and the timeout will be 1 second. So if you have something that will take more than 1 second, you might need to change that default timeout. But by default, those are the values. So every 50 milliseconds, we will go to check if clicked once is already in the DOM. If it's not, React Testing Library will wait another 50 milliseconds. That's the way that is working. And that is just syntactic sugar on top of the waitFor. And if I'm saying too much information now, don't worry, we will do code about those things. This is just to give you a broad picture of what we are going to do in the video, okay? Now, just to give you a little bit of context compared to the last video, in the last video, we did this getBy queries. Now we are going to go to those findBy queries. I also told you about these queryBy queries, and those queries, the only difference compared with the getBy is that the getBys, when they don't find the element in the DOM, they will throw an exception, and the queryBy, they will just return null. Everything else is the same as the getBy. Sometimes you might want to use the queryBy to make sure that an element is, for example, not in the DOM. And in the last video, we were always testing that it should be in the DOM. We will have videos later in this series where we will go deeper, so don't worry, this is just an introduction videos that we are doing before we start to go deeper. Now, in this video, we are going to go by this findBy, and while we are just using the single queries, you can also use the getAllBy, which will give you an array of elements, and the findAllBy, which will also give you an array of elements. Now, with that being said, let's jump into VS Code. Inside VS Code, if I run the tests we had from last week, you will see that all of them are still passing because I did no changes to this component. But if I come over here where we have the plus button and I change this synchronous code to something asynchronous like a set timeout, and I will say a set timeout of 200 milliseconds, for example, I will run the tests again, and you will see that at least 2 or 3 of my tests will fail. All the tests where I'm clicking on the plus button, all of those tests will now fail because I click, I expect immediately after to have a new value, and the new value will only be there after 200 milliseconds. So let's see which of those tests failed, and we can just come to the first test and fix that one, and we will do the same for the others. So the first test that is failing is this one over here, which is expecting the counter to be 1. If we go a bit up, we can see that in the HTML at that moment, the current counter was still 0. So that makes sense. Our test is failing, and we were expecting that. Let's just search for that test. Is our last test in the file. I can even focus this test over here, because I just want to run that test first, and then we will go one by one to the tests that are failing. And when I focus the test, all my before eaches inside those tests will still run. So in my case, this before each will run, and the next before each that will run will be this one. So those two before eaches are still running, even though I'm saying to only run this test. Okay, before eaches will still run. Now, with what I said, we can do one of the two solutions we saw in the documentation. Let's come to the first one, which is probably the better one for this specific use case, because we are not going to use this element anymore, right? I'm just checking if the current count is 1. I don't need that element to, for example, click on it or something like that. In case you needed that element to click again, it would be better for you to do something like label equals to await screen.findBy text, and then put the current count inside that, okay? That will be better, because then you could just do something with the label if you wanted to. In this case, for us, we can just keep that a waitFor, and now if I run tests only for that file, I don't run to run all the files in my project, I can do that counter.spec.tsx, and it will only run the files in that that I specify there. And because I only have this file as focused, it will only run that specific test. Now, if I remove this focus from here and I run the tests again, you will see that I will have 2 more tests failing. So when I find those 2 tests that are failing, we can come over to them, and the next one will be one that says we have 16. So let's search for that one, and let's just see how many before eaches we have, because usually this is where people then start to struggle. What we did in the other one was relatively easy, right? Now, in this one, you can see that I have the following. I am doing a click to add something into the counter, but in the before each before that one, I'm also adding something into the counter. So I have one before each adding to the counter and the other one adding immediately. And what's going to happen is that this one will add, it will wait 200 milliseconds. So let's say 200 milliseconds is over here. This one over here in line 35 will add immediately, and only 200 milliseconds after the first one will run, and the second one will run another 200 milliseconds after. And the way we have our code done, we will have a bug, because if we were doing something like C plus incrementer, that bug will not be there, but at the moment we are doing count plus the incrementer. So even if we do the same thing in this line that we did in the other one, let me show you. Await over here, await, wait for, it's hard. And I do this code over here. This code will still fail because we will use the previous value in the counter plus the increment. So let me show you that code failing still. We will still have 2 tests failing. And usually you have 2 options in this one. Or you go and fix the code here, but if I fix the code here, then I can't show you how to fix it in cases where you don't control the code, or you can't change the code, or you don't even know what's going on in the code, okay? And as you can see, I still have 2 tests failing, and what's happening over here is that I have expecting 16, but the counter is still 11 at this stage, okay? So let's go back into our code, and now I have 2 options. Or I will come into this line over here, and before running it, I will do an await for to make sure that the current counter is already, for example, 15 before I click again to be 16. That's one option. Or I will need to make sure that this specific before each, before it allows anything else to run, verify that every single action it did is already finalized. Usually, when you have a lot of before eaches depending on each other, I will tell you that that's probably the best solution, even though some people will probably not enjoy that much to see before eaches with code like this. Let me show you. A wait for, like that, right? Because now your before each is not only doing actions, but also waiting for something else. I prefer it that way because now all my code can become synchronous. So this code now, I don't even need to change it because it will just run as is. And the same will apply if I do it over here. So I can even copy this line over here, put it after my before each, and I can say that my before each will be 16. I need to say it will be asynchronous, right? And now I can remove all of this from there. I don't need it anymore. And so what this allows you to do is that the before eaches will have all the logic concerned to waiting, doing actions inside themselves. So all your tests can become just pure synchronous stuff. Okay, which in my opinion, I usually prefer, because now if I need to have another test testing something else, for now I'll just copy this one, but if I need to test something else over here that was also dependent on the counter being 15, I don't need to repeat that in like the 3 next tests if I had 3 over here, right? If this was testing something else that also depending on the same HTTP call or something like that, it will be easier for you to wait for that in the before each than having to wait for that in every single it test that you have. Some people will agree with me. Some people I know probably will not agree with me, but that's from the experience I have testing code and seeing a lot of code bases. This is what I feel makes people most comfortable and most confident on the tests they are doing, right? And as Kenzie says, it's all about the confidence we have in the tests and the code we are doing. If you want, I will now do just a commit, and if you want, you can do the same thing for this specific test. At the moment we have this test like that, you have the homework to change this one to be like that. And after that commit, I will start to show you how we can wait for elements to be removed from the screen. For example, let's say that you do an HTTP call and you have a spinner on the screen. How do you make sure that the spinner was there and now you are waiting for it to disappear, and only when it disappears you want your test to pass? I will show you how to do that and all the problems that you can have from that scenario. So let me just commit. Now that I already committed the code, let's say we want to add an element here on the screen, and this element will disappear after the moment that our counter is above 15, but it will only disappear 200 milliseconds after that happened, to simulate a bit of your spinner disappearing after your HTTP call is done. So I will call this one I am too small, because it will disappear after 15. So while it's not 15, it will be I am too small. And now we need some kind of variable, some state, in order to have that check for the if-else logic, right? So let's just create a big enough variable state over here, set big enough, and I said 15, right? So let's say default count bigger or equal than 15, and then we need to have a use effect where we are going to go over here in our use effect and check if the count is bigger or equal than 15, right? Then what we need to do is to do that set big enough, it will be to true. So at this moment is still synchronous code. So let's make this asynchronous code with our beautiful set timeout to, let's say, 300 milliseconds. So now we have that 300 milliseconds. We can come over here and say the following: big enough. If it is big enough, we don't show anything. If it is just small, we will just show that I am too small. And as you can see, when the counter is bigger than 15, we will run this set timeout, and this set timeout will only run 300 milliseconds after. So simulating a little bit your spinner. Now that we have that, if I come into my tests over here, I can kind of copy this one just to have the structure. I do that all the time, by the way. It's something that you probably want to do as well. And now I will just say it renders too big and will disappear after 300 milliseconds, right? So what we need to do over here is to use that await element to be removed. Let's just use that one. Wait element to be removed. And we will now do screen.queryBy text. And I just need to copy the text we put there. I don't remember what I typed. I typed I am too small. And I will just put it over there. So now this test should just pass. If I run that test, you will see that that test will pass because around the 300 milliseconds after, we add that bit before and then it disappears. In case you don't know how this wait to be removed works, it will first check that the element is there and only then it will see if the element disappears. So if the element was never there, for example, if I do this, the element was never there. So my test will fail at this moment because the wait element to be removed was never able to see that element there into the page. So that is important because I see a lot of people sometimes checking that the element is there and then waiting for the element to be removed. It's not necessary. waitForElementToBeRemoved does that automatically, okay? Now, let's put it back. Let's run to have it green. And when this is green, you will see that we have a slight problem over here. Let me ask you to stop the video and see if you can understand what bad is going on between those two tests and this before each. Okay, stop the video and try to do that. Now, if you are coming back from stopping the video, what is going on? We are literally going to 15, and after we go to 15, this test will run. After this test runs, we are going to destroy our component, but you will see that our component, after being destroyed, it will still have this set timeout to run. So React will immediately throw us an error or a warning saying that we are trying to change the state of this component after the moment that this component is already destroyed. So if we go up over here, you can see that exact error. Can't perform a React state update on an unmounted component. And unmounted component means just that component is already destroyed, okay? This is a no-op, but it indicates a memory leak in your application. To fix, cancel all subscriptions and asynchronous tasks in a useEffect cleanup function. So, because we are using setTimeout, this is a very easy fix. I will show you that one first, and then I will show you what you can do in your useEffect when you are not using, for example, setTimeout or something that you can cancel. So let's show first the setTimeout one because it's the easier fix, okay? And when you are calling a setTimeout, you will see that it will return for you an identifier. So we can call it the ID, for example. It's just good enough. And we can do the following. ID equals 2. And then here in the useEffect, we can just do return function, and this is the cleanup function. You can even call it cleanup. So if something happens, at least it's not an anonymous function in your call stack. So I like to name these functions still. And over here, the only thing you need to do is to do clear timeout, and you will do ID. And I think I imported something. Yes, I imported something that I didn't want to import. Now, when you do that, what will happen here is my component will be destroyed, this code will run, right? And the clear timeout is gone. So this set timeout will not run after my component has been destroyed. I can run my tests and show you that deadline is no longer there, but then I will show you how you can do if you are not using set timeout, you are using something else you have no control over, okay? So in case you want to scroll, you will see that there is no errors anymore. Now, let's say that for whatever reason, you have that specific line over there and you don't control, as I said. Okay, let's come over here. Let's, instead of having an ID, let's say something like if the component is still active, right? So I will do active. I will type this as a Boolean. And then over here, I will just do the following. Active equals to false, right? And over here, I forgot to put to true. And now instead of running the set timeout immediately, the only thing that I need to do is to come over here. Let me just put the curly braces to make sure that this thing will run perfectly first. And now the only thing you need to check is, okay, if the active at this stage is already false, I don't want to run this set big enough. So we can come over here and do the following. If active is there, then yes, you can set that big enough state, right? If it's no longer active, then you don't execute that state. And as you can see, this test will run and it will do exactly the same thing. And I see some people sometimes struggling with this, and one of the reasons they are struggling as well is because they have the waitFors and stuff like that, as I said, in their it and not in their before each. If you see what we have right now, if we were doing that in the before each, we would have no problem. And I will even show you that. So if I put this line into the before each, even though this line in this specific case doesn't make any sense to be there, okay? It's just to show you one of the reasons I like to put it in the before each, okay? But if you put that line into the before each, I can now even delete this test because this test is now a bit useless. And if I have that, even if I remove this active and I don't care about that active anymore, I will run my tests and you will see that I have no complaints whatsoever because all my components run to the end duration of that test. The only thing that we were doing, and that I see very, very often, is that people don't wait enough time in their tests for everything to happen. So what was happening is that this test was being killed and we have still React stuff running after that test was killed. So that's what you were saying, React, saying that that component was already unmounted and we were still trying to update the state of that component. This can be exploded in a million different ways, right? So if you have a specific use case that you are struggling, just put that in the comments. If a lot of people upvote your comment, I will 100% sure do a test with your specific use case to show you how you can handle that specific use case, because there are a ton of different variations that can happen out of this, all right? So I really hope you enjoyed this video. And if you want to watch video number 5, how to mock stuff and how we can do mocks, you can click there. If you want to just see the full playlist, you can click over there to see the full playlist with all the videos that exist in this React testing series. See you next week. Bye-bye.